We apologize for all computer incompatibilities around the world. With that in mind, we're only 6 minutes late starting, so I'd like to get going. Give you an idea of what we're going to do today. This is what I hope is the first in a series of many discussions that will become public for the development teams working on Bitcoin Cash. And the main goal of this meeting is to discuss the potential items for the next hard fork / upgrade to Bitcoin Cash, to determine which items are realistic to consider for inclusion in the May 2019 upgrade, and determine the status of each of the items listed, and if further discussion is required to solve any issues that there might be. So the specific issues, we'll go through them one by one. And I'm going to start now with doing some introductions. And so my top left-hand corner is Jason Cox. Jason, if you could introduce yourself, please.
Sure. Hi, I'm Jason Cox, Bitcoin Cash developer, currently contributing to Bitcoin ABC.
Thank you. Antony Zegers.
Oh, hi. Yeah, I'm Antony Zegers. I'm known as Mangarian online in forums and stuff. And yeah, I work on Bitcoin ABC.
Great. Amaury, introduce, please.
Yeah, so I'm Amaury. I'm a lead developer of Bitcoin ABC.
Mark?
Hi, I'm Mark Lundeberg. I'm just sort of getting into Bitcoin Cash and trying to help out with the development process. Just getting started.
Thank you, Mark. Emil?
So I'm Emil Oldenberg. I'm the CTO of Bitcoin.com.
Okay, thank you. Chris?
Yep, Chris Pacia. I work on OpenBazaar and also the BCHD Bitcoin Cash full node.
Okay, thank you. Andrea?
Hi, everybody. I'm Andrea Suisani. I'm a Bitcoin Unlimited developer.
Thank you, Andrea. So we have a small group with us today, and we're going to cover a number of subjects. As I said earlier, the main goal is to determine what's realistic to be included in the next upgrade. The items that are going to be discussed, I'll just run through the list of them first, and then we'll dive right in. The first item is BIP 62 items, and I'll just read what was written. Does it make sense to activate the remaining items, null dummy and minimal data push? Should clean stack be reversed? Second item on the list is the 100 byte transaction size. Should that be changed? What is the best approach for this? Third item is Schnorr. Is there any chance this will be ready in time? What needs to happen to progress this item? And fourth item is OpCodes. Is anyone motivated to take responsibility for these? Someone needs to take ownership and work on it if it is to be included in the upgrade. Should only be activated, mul invert, question mark. And then the last item is there any desire to rework the Sigops Accounting? So I think we'll throw it open for discussion with BIP 62 items. Would anyone like to dive into discussion on BIP 62? Jason.
So just to get started, I wanted to make sure everyone here understands kind of what BIP 62 tackles. My understanding is it's primarily about malleability. And recently, what was implemented in the last hard fork was the implementation for clean stack and enforcement of clean stack. I also understand that enforcing this has caused some addresses to be unspendable. like people spending SegWit UTXOs on BTC, sending the same UTXOs on Bitcoin Cash is now impossible. If someone thinks this is incorrect or inaccurate, please add to that, because that's my understanding so far.
Well, just to clarify, I think it's basically when people accidentally send Bitcoin Cash to a SegWit P2SH address. So yeah, it shouldn't be a normal thing, but I guess people are doing that by accident. And the clean stack prevents miners from being able to like save the people's money.
So people cannot redeem their SegWit coins or on BCH right now.
Well, if someone accidentally sends Bitcoin Cash to a SegWit address, like basically you need to get a miner to help you recover that, because anyway, it's hard to explain. Basically, anyone could mine it, I guess. So the miner, you have to have a trusted miner to be able to get your coins out of there. So I think there has been in the past a few miners that have been helping people out to recover their coins when they do that. But I mean, I guess I don't know if that's still. I mean, I guess my suggestion would be someone needs to find out if this is a big problem, or if there are actually miners still willing to help people out with this. I don't really know if that information is.
As far as I know, BTC.com is still doing it.
No, it's not possible to do it since the last fork. So I think we have our first action item here is to make sure everybody is aware of what's going on.
Yeah.
Do we know the scale of the impact? Like number of users, amount of money that is now unspendable due to this?
We have no way to know.
Okay.
Like we would need to index all SegWit addresses first, and then check the UTXO. So that's it takes a while to do that.
But there's no way to know because they're P2SH. So all you know is points on a P2SH address.
Does it apply to both the P2SH and regular SegWit?
No, just P2SH.
Okay.
So I guess in terms of BIP62, I guess my impression of it, or my take on it, is there's basically no point. Like, you kind of should do all of it. Like, if we have some hope of doing all the items, then maybe there's some value to that. But if you still have even one malleability thing left, there's not much value to just doing one or two. So I don't know. Like, unless there's some motivation to do all of them, maybe it would make sense to change this. But yeah, it would also make sense to know what the impact is.
I'd just like to say one thing, which is it is in principle possible to have all the BIP62 relevant things, like to have all the third-party malleability fixed without breaking any coins, but it requires a little bit of a different approach. So it would be like it would be a new hard fork to move to that sort of approach. So one thing that might make sense is even to just roll back what we have right now and then put in something better later on, or I don't know. That's possible.
So for that something better, are you saying like a new transaction format or something like that?
Oh no, just so for example, you could say that you only apply the clean stack rule to the pay to public key hash and pay to script hash multi-sig, like very standard sort of transactions. That would be one way to do it. I don't know if that's convenient, but you would say that every other script would have to manually check by itself using opdepth. And if you don't want to be malleable, or if you don't want your transaction to be malleated, then you have to use that sort of additional mechanism in your script. So it's kind of a workaround, but that's in principle possible.
Got it.
Is there any further discussion on this item? All right.
Well, I think that what Amaury said about an action item, we should maybe try to make that concrete so that someone actually does something.
So I guess that it's a matter of understanding if we want to fix all the third-party malleabilities that BIP62 is fixing. If yes, then we have to go forward and then have a measure of the amount of coin that are locked in P2SH SegWit addresses, if it is possible, in some way. And once we have these two data points, we can decide what to do. Otherwise, if there is no coin locked in this P2SH SegWit addresses, well, we could just go ahead and keep the fix that we have now, and then once we assess if we want to the other fixing in the next hardforks, well, we could do it, but we have to assess what we want to do first, and then and understanding what's the measure of the problem that we are tackling.
So to kind of add to that question of the impact, is it only the SegWit style addresses that are impacted, or are there other use cases that we haven't discussed? I know the SegWit one is the common one. Because if there isn't, maybe that helps limit the known impact.
So the flags that have been activated have been standard for quite some time. So you'd need a minor corporation to spend those coins no matter what.
Okay.
But
So
it's not that hard for miners to add APIs and tools for their users, or anyone actually, to just submit those transactions.
Is that something is that something you guys could do, Emil? Like try to, since you actually have users,
Yeah.
like someone who has users, like we need to
It's actually
problem.
It's actually something that we have considered, to add an API where you can submit non-standard transactions, but only like if they follow like a specific format, so we don't mine crazy non-standard transactions.
No, I mean, I was just talking about finding out if there's a problem with people accidentally sending their coins to these addresses, if that's an issue or not. Like, have you guys encountered that, or?
We got a few requests after the Bitcoin Cash hard fork, but that was a long time ago.
Yeah, nothing recent.
I think
I don't actually know the status. You would need to like index all SegWit addresses on the BTC network first, and then run that with the UTXO on Bitcoin Cash. So that's a quite large data set to go through.
Some people are doing that deliberately, though, because the SegWit addresses are anyone can spend on BCH. So what was happening in a lot of cases where as soon as somebody spent their SegWit coin from the same address, it would some unknown miner would come in and just gather up all those accidental Bitcoin Cash coins on those UTXOs, because any miner can take them once the redeem script is revealed.
Yeah.
so. Actually, now we have a better situation that we had before the last fork, because miner can't take the coins for them. Like they are stuck for everybody, right?
Yeah.
But is it better or worse?
I don't know. It's different. Sorry, I should have chosen a different word, but it's different, definitely.
So in addition to the impact, we should be determining how many people perceive this as something that needs to be fixed. Because, you know, maybe there's a large number of UTXOs potentially impacted, but if people don't feel strongly about it, then maybe it's not worth fixing.
I guess that from my experience in the first few months after the August 17 fork, I have heard from fellows and then also other people on the internet, Reddit, whatever, complaints about the fact, not complaints, but basically people that wrongly send BCH to BTC, but this fade out, like since we have the new address format and other thing, and people get more used to the fork, basically. But it could be just that I am in a bias bubble, but I don't know. And it's been a very long while since I've heard someone tell me that there is some kind of accidental sending from BCH to BTC, but just an anecdote, nothing more.
All right, with that in mind, suggestion to move on to the next item, if there's no objections. The next item is...
Wait, before we move on, maybe we should find an owner real quick, just for someone to follow up on the impact. Emil, are you able to take that? Is that something Bitcoin.com would be interested in looking into?
I'm not sure we can commit to that right now, but we have a lot of things on our plates.
Yeah. So basically, I guess the status of this item is we just need more information, seems like.
Okay. All right, with that, we'll move on to the next item then. The 100 byte transaction size, should it be changed? And what is the best approach for this? Who would like to start off on that end?
I can start off on that. Yeah.
Thanks, Mark.
Yeah. So when the last consensus change was happening, I was pointing out this 100 byte limit. You know, in principle, it could affect some transactions. So there were like 10 transactions since the August 2017 hard fork or something like that. 10 transactions only that were less than 100 bytes. I think 4 of them were Coinbases, something like this. So, it could be relaxed to 64 bytes to have the same intended effect. So just to remind everyone, the intended effect here is to prevent a technical vulnerability in the Merkle tree that you can have you can have a node that looks like a leaf or something like this. I don't remember the exact thing, but you could relax that to be a 64 byte limit, and that would be certainly enough for everybody, I think.
Yeah, so this rule actually creates headache for the mining pools, because there's another rule that says that I think it's the Coinbase input can only be has to be larger than 100 bytes. No, wait, it cannot be larger than 100 bytes. And the total transaction cannot be smaller than 100 bytes. So there's like a lot of extra rules that you need to add to the mining pool to make sure that you don't accidentally mine Coinbase that is too short. Because the way mining pools work is that you configure the mining pool in a config file to specify the mining pool name. And if you start a mining pool and you want to be anonymous, you don't put anything in the Coinbase. So if you want to, so it means that you need to fill up your Coinbase message with random garbage if you want to be an anonymous miner. Because it's only anonymous miners that risk mining a Coinbase smaller than 100 bytes. Like if you add your mining pool name like pool.bitcoin.com, this is usually not a problem. But if you don't want to add anything, then you might risk mining invalid blocks.
So would it make sense dropping the transaction size limit to something like 80 bytes? Is there any use cases between 64 and 100? I'm not personally aware of any.
But if you're going to change it, why not just do it since we have to change it, why not saying everything higher than 64 is okay, rather than put an arbitrary 80 or 90? We have to change it. I would even go further and say everything different from 64 bytes. I find it more logic rather than put another random number.
Yeah, I've heard this argument a lot, and it does make sense to me. The only thing is usually you want to design a critical system like this to have the behavior that you're looking for, and it should match the use cases that you want them to match. So when we're talking about transactions that are below, say, 80 bytes, and I've asked a number of people this, like, what are the use cases for these really tiny transactions? And I haven't heard anything very useful other than the exploit, which I guess is a use case technically. So by simply saying you can't have a transaction smaller than 80 bytes, you're limiting any strange behavior that was not intended by the system. It makes it easier to devise the system to be like anti-fragile. It's not that we're tackling any particular exploit, it's tackling exploits that are currently unknown.
The thing is that we are conflating two things here. Before we introduced the constraint on the transaction size, what was the situation? Like, there were no, that I'm aware of, there were no constraints on size like 80, 70, whatever, right? We didn't have it. Okay, cool. So we are saying now that we probably made stricter than we should have done, and we are going to relax it. And yeah, this is the first thing. And the other thing is, since we are designing a very mission critical system, we want to while we are changing again, we need to think carefully if we want to move to the situation we have before, or if we just want to relax the constraint a little bit, like 80 bytes. And I see your point, but it's like we are mixing the two things here. There is two things on the plate. The first one is we want to go back to where we were before, and the second one is, well, maybe where we were before wasn't so thoughtful like we should have had in the first place. So just want to underline that.
Sure. The only thing I'd want to add to that is it's easier to drop this limit than it is to raise it. So if let's say we do drop it all the way down to 64, and then we later find out, oh, there's a somewhat malicious use case at, let's just say 65, raising that limit back up is a little bit more complicated in terms of deployment. But other than that, there is not a strong case for it.
But you say that it's more complicated because you are more strict. But since I think that we are going to introduce this hypothetical rising in this constraint via an hardfork, right? So I guess that, yes, it is more complicated, but it is an hardfork. So people need to, at least for full nodes, talking about SPV wallet will be different probably, but yeah.
What's more complicated? Is that because you need to search through the mempool and find the violating transactions or something at the fork time. Is that what it is, or?
But this is something that this is a complexity that should arise when in the period of time when the fork is activated. Yes, I think this is one of them. But it is something that, as far as I'm aware, all the full nodes that I know the code of have a mechanism in place to purge the mempool during this activation time, and also if there is a rollback, that there is the code to look after it, like dealing with transaction differences between the two states. But yes, this is one complication indeed.
Anyone else like to weigh in on the possibility of changing the 100 byte transaction size?
I guess just as an implementation detail, is it going to be the case that it's the size is kind of retroactively reduced? So, like, I mean, barring putting any kind of checkpoint aside, like after May, would you be able to go back and start a fork from before May with a 64 limit or something like that, or would we have to maintain two limits? So, like, if the height is between these particular ranges, then the limit is 100. If it's after May, then the limit is 64 type deal.
So in terms of software maintenance, I think it would be really bad to enforce the retroactive limits. I don't think this would be positive for any implementation to do so. So in theory, yeah, if we changed it to only 64 bytes being the excluded transaction size, then you would in theory be able to go back to the fork point and start mining, 65 or 80 or 90 byte transactions. That would be valid. At least that's the way I envisioned it. So are we able to determine an owner for this? Just so, like, this doesn't have to be a person that implements it on all the node software, for example. It's just someone who kind of drive it and stay in communication with everyone and make sure it's done. Maybe writing a spec, some notes on why we decided to, tweak this constraint.
I could take it.
Okay, thank you.
You're welcome.
Andrea, you've taken on an item. That's great, thank you. Antony, did you have any comment on this?
Oh, not really, no. I mean, I guess my overall take on it is that it's, like maybe it wasn't the perfect thing to do, but I sort of wonder if now that it's in place, if there's really like a strong motivation to change it again. But I guess that's part of what Andrea can investigate, maybe.
Great. Any other final?
Yeah, it's sort of like the last one. Like, I just feel like we don't have enough information to really know.
Right. Anyone else want to comment on this? And we'll move on to the next item. Hearing none. Next item on the agenda is the Schnorr. Is there any chance this will be ready in time? What needs to happen to progress this item? I'm going to take a stab in the dark here. Amaury, would you like to speak on it?
Yeah, so there is an implementation of Schnorr that I've made like more than a year ago now. It's not been through the kind of review required that I would feel confident to deploy that in the wild at this point in time. And if that doesn't happen very soon, then we won't be able to deploy Schnorr in May. We have like 1 month and a half. And in addition to the algorithm itself, we need to integrate it into existing OpCodes. So it's it requires some time in itself. So if the review of the algorithm itself doesn't happen very soon, this is not going to happen.
Can you briefly touch on the use cases for the people listening in on this?
Yes. So Schnorr is an older signature algorithm than ECDSA. It's more flexible in many ways than ECDSA. The reason why ECDSA become more of a standard than Schnorr is because for quite some time Schnorr was patented. So this is actually the #1 use case for ECDSA, and the reason to be for ECDSA is to provide an alternative to Schnorr that is not patented. So Schnorr has advantages in terms of validation because we can do what we call batch validation, meaning you can take, for example, egg signature and do some computation that verify the egg signature, and that computation is not as expensive as checking 8-time wine signature. Right, so when we have plenty of signature to check, which is the case when we receive a new block, then this is very advantageous to be able to do that. That's one big advantage. From a user perspective, it's also interesting because user can do aggregation and multi-sigs and stuff like that look like just like regular signatures. So this is an increase in privacy for those users. And this is also better for the network itself because it just has a signature to verify, regardless if it's a regular P2 key hash or a multi-sig or whatever. In all cases, it looks for the network like the same, and it's just one signature to check.
Any other discussion on Schnorr?
I guess I'm just curious, like for the review, like do you basically need guys or people who can look into the crypto math and all that kind of stuff? Is that kind of what you're looking for? Or?
Well, the math itself has been out for many years now, so that part is fairly well covered. But when it comes to cryptography, you need to implement that in ways that are very specific. You need to make sure you don't leave somewhere in memory some piece of secret data that some other code on the machine could not, go rumble through the memory that you left behind you and find some secret data. You need to make sure that you implement it in such a way where you have no branches and no memory access that depend on the secret, because then you have side channel attacks through the branch predictor of the CPU and through the cache hierarchy of the CPU, which likewise allows some third party to recover information about secrets. So there are all kinds of very specific stuff that you really wouldn't care about in general code that you need to be careful about for this kind of code. So it needs, and those are not stuff that you can test really. So it needs extremely careful review. It needs the kind of review. It needs way more review than a regular piece of code.
Just a comment on that, though, the parts that are necessary for consensus, for validating blocks and checking transactions, that sort of thing, those wouldn't have any secret data. So do you feel more confident about those parts? Like the parts that are not generating new signatures, let's say?
Yeah, so that's true. There are other pitfalls for those parts, but obviously there are no pitfalls with private data. Those pitfalls may be, so for instance, there are various places in the code where you would hash some value and then check that the result of the hash is a valid scalar as per the elliptic curve that we use. And the thing is, the scalar is like not 2 power 256, but a number that is slightly smaller than that, but it's a number, that starts with a bunch of Fs. So it's actually very difficult in practice to find a pre-image of the hash that's going to fall into that range. But so it's very difficult to provide actual tests that are going to trigger that code, right? But you need to get all of that correct anyway, because maybe at some point some dude is going to find the one value for which it can produce a hash within the right range. And at this point, you get a chain split. So, that's another kind of pitfall that you need to be very careful about, and that it's going to be uncovered via review more than by testing, because we don't know of any pre-image that fall in the right range at the moment.
So, I mean, we've got, I guess, a couple different ways that Schnorr signatures could be implemented. It seems like the simplest way is to kind of just overload the existing opchecksig, but that also seems like the most dangerous way to do it too, because we're essentially exposing all UTXOs to this new code. I don't know what you guys think about, like, the security of that or not. I mean, that seems like the nicest way to do it if it was if this was like really battle tested stuff, but it worries me a little bit that it's like new and it's exposing all the old UTXOs to it.
Yeah, that's why this has to be done perfectly.
Yeah, I would add to that the security assumption made by Schnorr are the same security assumption made by ECDSA. So if you were to find a way to break the Schnorr signature algorithm, that would most likely means that you can break the ECDSA algorithm that we currently use.
I guess you did make one comment though about reducing the number of branches. I know this isn't exactly the same, but by implementing another signature scheme on old UTXOs, it kind of feels like we're introducing a branch where it's basically you can, there's a couple different outcomes you could get in order to sign a particular transaction for old UTXOs, and that it doesn't feel right. Even though what you said is the assumption is the same for both, it does make you kind of squirm.
Yeah, and I don't. So those branches, I don't see them as the most risky ones, because this part of the code is 100% deterministic. If we are talking about the interpreter, so it's very easy to have like all the unit tests that we need that make sure that this part of the code is not going to do something weird. Generally stuff like interpreters and compilers are, very easy to unit test extensively. So I'm not too worried about putting a branch there. I would be more worried about, putting a branch in the network layer or the DB layer, or, like anything that is multi-threaded or depend on how fast third party reacts, But that part is very easy to feed input and check the output.
Anything further on this item?
We will need an owner because Amaury has been asking for review on his Schnorr code for a little while now. Someone to kind of drive this review home over the next month and a half, like you said. Otherwise, the review can be ongoing, but it won't make it for the next hard fork. So it depends if we view this as valuable enough to put a lot of weight behind it in short order.
Yeah, I can take that. I've been writing the Schnorr opcode spec so far, and I think there's a little bit of controversy there with exactly how it's done, but perhaps if the concern right now is getting a sort of a cryptographically secure implementation, I can review that at least, and try to get people on board with that.
Yeah, and I'll talk with you after, because I want to talk about getting more reviewers, maybe even potentially some people outside of the Bitcoin Cash space, because I think this is something that can be reviewed by, cryptographic experts and that sort of thing.
Yeah, that's true.
And I think it's fairly clear from this call today that, there's an invitation for people who are going to be watching the recording, or any of the attendees right now. If they have an interest, they can contact you guys directly on that. So, great. If there's nothing further on Schnorr at this time, we'll move on to OpCodes, the old OpCodes. And Jason, maybe I'll get you to help me with this. And what I have written down here is anyone motivated to take responsibility for these, someone needs to take ownership and work on it if it is to be included in the upgrade, should only be activated, should only some be activated, for example, mull or invert.
Right. So we actually have diffs available for, I believe, all of those opcodes that were recommended for the hard fork. There is review that needs to be done. There's tests that need to be written. But other than that, the implementation is more or less completed, is my understanding. I guess, Amaury, you can correct me on that if I'm wrong. So really, we just need someone to own this, make sure that there is a complete spec available, that there's plenty of unit tests that are available, so that all the implementations can go and implement these and make sure that we're all building the same thing. This is mostly an ownership issue as opposed to, writing code and implementing it.
So there is one issue, or at least potential issue in the overflow semantics of various opcodes. This is something that have been raised in the opcode group at the time when Enchain came to us with those opcodes. Because the number system use one complement in Bitcoin instead of two complement, like regular way of all the state of the art I'm familiar with working on compilers essentially is completely moot, completely useless. So we need to have someone look into the overflow behavior and make sure that it does make sense and it does what we expect. As long as there is nobody that is willing to do that work and be reluctant to implement stuff like opmull that can overflow. Things like invert, for instance, or shifts can be implemented, but they need someone to take ownership of them and track that to make it happen.
Yeah, I mean, I guess just to throw in my 2 cents, I don't know if there's much value, but I guess my impression of this whole thing is that everyone essentially agrees in principle with having these, but no, it doesn't seem like anyone's super motivated to actually make it happen. So yeah, that's kind of my impression. The other thing I was wondering, I don't know, I guess for the shift, the L shift and R shift, it seemed like there was some discussion about whether that was done in the best way or not. So I don't know if that's an issue or not either.
Yeah, so that was discussed, and the question is, because the number not only are one complement but are all little Indian, even internally, you end up with shifts that cannot work with binary blobs and numbers the way you'd expect on a regular instruction set. So at some point you need to choose, and it's gonna be broken for one of the two. And the decision that were made at the time was that it's more useful to use shift on binary blobs than it is on actual numeric values. And so this is what people went for at the time. I don't think there is any new information that invalidate that conclusion that came up since then.
Just by any chance, do you recall any of the use cases that people had envisioned for the binary shift, the binary blob shift?
Yeah, so generally, like you may want to push some data on the stack and either cut that data into pieces to verify some part of it or aggregate it. So maybe in the case of an oracle, for instance, you may have an oracle, and so you have some data that is provided, and you have a signature on those data, and then you have a part of the script that verify that those data contain this or that information. So in those cases, stuff like split and shift and stuff like that allows you to select pieces of the blob are very useful. Yeah, that's the main use case.
But you can achieve that already with split. It's a little redundant in some cases.
Yeah, so you can do that with split. Split only allows you to do it at the byte granularity. So maybe like if you want to put a series of flags, for instance, you may not want to have 1 byte per flag, for instance, and do a shift and a mask and know you get the value of the flag. You can do more granular stuff with shift than you can do with split. But you are correct. Like it's not like it's enabling anything new. You could do all of that without the shift, just like you can do upmul with a bunch of additions and a few if statements. But it's generally useful, I guess.
So that said, looking for an owner, I would actually like to take this one myself, except my time is constrained and I'm kind of stretched thin across some other things at the moment. I think everyone here might be kind of in that same boat, but does anyone know anyone outside of this meeting that may be interested in taking this as an item, writing the spec and making sure the test coverage is good on those specs?
I could ask to other BU devs if there is something interested in, but not sure about that because we included NJ implementation in the SV client that we produced, but we just bring the code and plug it in just to be sure to be compatible bug for bug. Like we didn't change anything in terms of code. The review has been done, but not as, like Amaury said, not as thoughtfully like it should have been. So could be that some of the guys in BU wanted to do that, but I can't say for sure. I could ask.
Yeah, could you do that, please, and get back to me with that, because maybe we can coordinate on finding an owner for that.
Okay.
Thanks.
Thank you, Andrea. Moving on to the next item then, there's no further comments. Is there any desire to rework the Sigops Accounting? Antony, you brought this forward. Do you want to speak to it first?
I mean, it's one of these things that it's kind of always been hanging around as an issue, and it's not really urgent, but it's I don't know. I guess I just figured it was worth adding to the list. It's a little weird right now how the Sigops are are counted. It doesn't really make sense in a few ways. So I guess in the long term, it seems like it's something that should be dealt with eventually, but it also doesn't seem like it's super urgent. So I don't know if anyone else has thoughts on that.
Yeah, just to kind of add to what you said, basically the Sigops counting is done on a per megabyte basis. So it like packages up the first megabyte of transactions and then counts the Sigops and then does that for the next megabyte. What it really should be is the Sigops over the entire block and making sure that the Sigops per megabyte is lower than a certain value.
It's not the only problem though. The way Sigops are counted makes zero sense whatsoever.
Yeah, it's overly complex for no reason.
Yeah, so I guess the idea, like the way it's counted, it doesn't really make sense. So, sorry. So it seems like if you're gonna change something, you may as well make it right. So I guess that's the issue. Is it's a bit of a bigger change than just.
Yeah. So making it right. You need to essentially count the number of Sigops as you execute them to know what number of Sigops you actually did in that block. Because right now it's counting Sigops in the output of the transaction that are not executed in the block. It's not counting various Sigops that are in the input, unless they are P2SH input, in which case they are counted. The whole stuff makes zero sense and doesn't even reflect accurately the number of Sigops that are required to validate the block.
Yeah, to summarize, it's basically just a bunch of bad heuristics.
Yeah, like the multi-sig thing is weird. It counts as 20 all the time, no matter what, and stuff like that. It's really bizarre. So anyway, I guess I just have, in keeping track of of like the various items, I just thought I would raise it as an issue, but I don't think anyone's. I don't know. I just to keep it on the radar, but. Yeah, I don't know if anyone has an interest in working on that or not.
I was aware that Andrew Stone was thinking about it and has some idea on improving it, but as soon as he's not here, I can't speak for him. Another question: is it actually possible to follow the path of correctly counting the Sigops via executing it while validating a block, or is it an overkilling and having a better set of heuristics would do the trick? Like, do we really need to go through the exact accounting for all Sigops, or something? A better estimate would suffice.
No. So counting, like doing +1 to some variable when you verify a signature is like probably not even gonna show up in any kind of profile, right? But the way Sigops are counted right now, not only is like not accurate, but it's actually fairly expensive because you need to parse all the scripts twice. One to execute them and once to count the Sigops with the heuristic that we're using. So it's probably going to be faster to do it as we execute. There is one tricky situation that we need to make sure we take care of. Is when you have a transaction in your mempool and you cache the result of the script execution, you need to make sure that you also remember how many Sigops were done during that script execution. So
we need to extend the cache to cache also the counting of Sigops for the the cache of the execution of the transaction.
Yes, yes. So we need to make sure that the cache keep track of the Sigops count if we want to cache anything. But beside that, there is no major order, and it's probably going to be cheaper at the end, not just more accurate.
Okay.
Yeah, I mean, I mostly agree that it's something that it would be nice to fix at some point. I don't know if this coming hard fork makes the most sense, because it seems like something that takes quite a good deal of planning, like much more than, say, those OpCodes in particular. I did have a question what Jason was talking about with the way it currently handles it on like a per megabyte. It sounded like my code might actually be wrong on this, because what I do is just take the Sigops per megabyte and like multiply that by like the excessive block size to get the max Sigop count. Is that not the way you guys handle it?
Yeah, no, that's not correct. The way it's done right now is that you take the block size, you round it up to the next multiple of 1 megabyte, right? So if the block is like 1.2 megabyte, for instance, you round it up to 2 megabyte. And then you apply a limit of 20,000 Sigops per megabyte. So if the limit that you computed is 2 megabyte, you multiply 2 by 20,000, and you have the Sigops that you can accept.
So it's not based on your excessive block size then?
No. So the way you do it is probably fine as long as you follow the chain. If you want to be a miner, like if you want to mine with BCHT, you need to fix that.
Yeah. Okay.
Yeah, I think that we just demonstrated the confusion around the current implementation. Like, we would like to fix it so it's much simpler, like what you described.
I'm actually surprised by how generous the limit is. It's like one check sig for every 50 bytes or something like that, which is more than you could normally do, in many circles.
So there are reasons to do that, mostly due to historical factors and to the way Sigops are counted. So you can actually get a density of Sigops that is higher than that fairly easily. The reason is it counts Sigops in outputs. So if you have a bunch of pay-to-script hash output, each of them is like less than 50 bytes. So if you have a bunch of transactions with a bunch of outputs, like, a ratio where they have way more output than inputs, it's actually going to run into the limit. It's rather stupid. It's it's because it's counting the wrong stuff.
Yeah.
Any other comments on reworking the Sigops accounting? Okay. I also have listed any other items to consider, and this is specifically for the May 2019 upgrade.
I have one point I would like to bring up, or at least float the idea. So currently, since the Bitcoin Cash hard fork, we have kept increasing the block size, but one limit that has not been touched is the chain of unconfirmed transactions. So I would like to float the idea that this limit is raised. The problem is, like, we've been doing some experiments with this, and it's a big headache if nodes are not configured the same. So the only way of actually doing this would be that everyone activates new rules at the same time, which would be at a hard fork time. So this is not a hard fork rule or anything, but it should be, if this limit is raised, it should be raised at the same time as, it should be activated at the same time as the hard fork. Just to make sure that all the nodes have the exact same configuration.
Yeah, so you're correct. We actually run into that before when we changed the size of operator, where you do it in synchronization with the hard fork, even though it's not a consensus change per se. But if you don't do it with an activation point, you end up essentially completely breaking zero confs. On the topic of especially chaining transaction, I agree that we want to get rid of that limit at some point. However, right now, because of the way the software is written, every time you accept new transaction or remove transaction from the mempool, you do a graph traversal of all the childrens and parents of it. And so if you don't limit the depth of that, you may end up doing actually expensive. Like it's not a computation that grow linearly. It's like exponential or factorial or some stupid, complexity like this. And so you run very, very quickly. You expose yourself to a lot of resource usage when you increase that limit. So I would rather rework that code so it doesn't do anything stupid, and then get rid of the limit altogether.
Yeah, there was actually a study done not too long ago. I'm seeing if I can find it. But someone had profiled, different chain lengths to see how poor the performance was, and it gets really bad. If I remember correctly, at around it's like 50 or 70 chain transactions. But that said, Emil, do you know if there's any direct positive impact to raising it, because it's currently at 25? Does it make sense to raise it to 35, 40? Or is that raising it just by that much not enough?
Yeah, so like we do get some support tickets once in a while. So like if you, for example, try to play Satoshi Dice too much using our wallet or any kind of wallet, at some point you will probably reach the maximum chain transaction rule, and you will get weird error messages that the users doesn't understand, and they're just angry and email support like, why can't I play Satoshi Dice? What is wrong? And that's because Satoshi Dice, if you win, you get one transaction back, so you can only play it. So you can only play it like 12 times, and then you hit the limit. So if you win 12 times, which you can do if you're playing on the easiest bet, then you've got to have a lousy user experience. And we are, so like, I know they have that problem, and we get the support tickets for it in our wallet. But also we are ourselves building another on-chain dice game, and we are also building out other on-chain services that would help if you can send a few chained transactions.
Yeah, there are some web wallets as well that generate a bunch of chain transaction. I'm thinking, even though they went with SV, I'm thinking about Money Button, for instance, that, every time you use the Money Button, you chain the transaction with the previous one that you made. So you get the same kind of issue that you get with Satoshi Dice here. So there are a few services that would benefit from more chain transaction.
Yeah, also like memo.cash, they're saying like they had to do all these workarounds to be able to send more than 25 messages per block, per user. So, no, they worked around it, but that's kind of painful.
No, if we remove child pays per parent, the raising this limit, I think, becomes significantly easier.
Yeah.
Yeah, but child pay for parent is somewhat of a useful feature. But right now,
is anyone using it?
Yeah.
Bitcoin Unlimited doesn't have it, for example.
I think they merged it like last year.
No, we don't. We don't.
Okay.
But I think that limiting children pay for parent to some depth, like I don't know, not going back to nth level of ancestry, like only the parent could limiting the length of the children pay for parent transaction chain could in the time that we are going to rework the code that go through all the unconfirmed chain could be a temporary solution to have a significant increase in unconfirmed transaction. Yeah,
there are two problems. One is child pay for parents, and effectively we can solve that one by just limiting the depths at which we do child pay for parent to 1 or 2 or something small. The other one is Sigops accounting and size accounting for block construction. And this one require essentially what we know we did, but this is one more reason why we require to overhaul the way we do block template construction.
So if we're able to limit the child pays per parent relatively easily, would it make sense to coordinate for this fork bumping the chain transaction limit up to 50? Essentially doubling it without having the performance impact.
I guess that if for BU, there's no problem. We don't have children pay for parents, so we are okay. We even tested it with very long chain of unconfirmed transaction in the Giga block testnet initiative, and there were not among the bottlenecks that we hit. So we are okay with it. But for other implementation that have children pay for parent, I guess that once you measure that there's no performance impact, once you put in place a constraint on the length of children pay for parent and rising the at the same time that the length of a confirmed transaction in the mempool to 50, why not? So that Bitcoin.com and Satoshi Dice could have the warning, the error, and then the whatever complaints that comes through at 24 or 25 winning streaks rather than 12, so that the number of tickets opened would be decreased significantly. Why not, if this is the case?
Child pay for parent is not going to be the only issue. Like the whole accounting of Sigops and size for block construction, get block template, it's going to be another one. It requires also arbitrary traversal of graph when you add and remove transaction from the graph.
Okay, so what about gathering a bunch of data? Also, maybe rehashing the study that Jason was mentioning before to see if we could have a reasonable increase without hurting any other part of the system. Like if we achieve, we said something like 40 or 50 without impacting get block template or children pay for parent or whatever, why not? Just measuring it and then decide. If we have something like under 5%, 2%, or even 0%, we're not doing it. It's not the final solution, but it could be a stopgap issue problem. A band-aid for the problem that we are facing.
Yes, I wouldn't be against it though. I mean, it's not really a technical argument, but like all those people that run into that problem would appreciate the app. This is open source. This is open source. If someone care about some problem, they need to be helping us. We cannot be, just like doing.
I guess that the measuring of the proposed change in the default policy, like having an ABC client, setting the default to 50 rather than 25 for the ancestors and for the children length of the chain, and measuring the impact on get block template, RPC, and whatever other.
So you want to measure that. You also want to generate input that are purposefully hostile, right? Because you don't want someone to be able to bring down the network by just sending a graph of transaction that just send the software into into doing crazy amount of computation.
But isn't something that someone could exploit already if there is some pool that use known default value for these parameters?
No, because this accounting happen in the mempool. So you could receive blocks with deeper chain of transaction. That wouldn't be a major issue except for block propagation because you won't have it in the mempool.
Yeah, so like right now, any pool can just configure it any way they want. They mine 100 transactions if they want to. But what we discovered is that if you have nodes with different rule sets, then they may get out of sync.
Yeah.
And suddenly your nodes have valid UTXO that other nodes doesn't have. So your node is trying to send transactions and forward transactions that are seen as invalid by other nodes.
Okay, so actually is a policy that is more consensus related that we thought before,
No, it's not really consensus. It's more like your node might end up with UTXO that doesn't exist on other nodes until it's included in a block. Okay,
so the matter is that we are going to, if there is different settings for these parameters in the miners and in the network, that means that block propagation and transaction propagation will be hit, and so that at the end of the day we will have higher block propagation time, right?
Yes, so everyone has to change at the same time. That's the only way to fix this, and the only way to do that is to activate it at a hard fork time. And yeah, so it seems like it's not that easy. Maybe it's not that easy to just raise the limit, even though that will be helpful now. Just raise it a little. But yeah, like everything in every Satoshi clients, everything just needs to be rewritten and fixed.
Yeah, so I think we have a bit of a cultural issue generally within BCH here, because everybody knows that these things need to happen, but nobody is stepping to the plate. The previous change that happened for op return, for instance, we had to finish it, right? Because we received some patches, but they were not high quality enough. And we had to finish them ourselves. And it's been the same for many other changes. The thing is, people who care about some change, they need to be stepping up to the plate and making that happen, because those changes, they don't happen magically. They don't materialize without thin air. If nobody is doing it, then it's not going to happen.
So in this case, for this to happen, we need to refactor more code.
Yeah, and we've known that this code needs to be refactored for forever. So we can say it's a big chunk, but if we don't start, we never finish.
So like it was discussed earlier, Amaury, if we could do a stopgap to limit the depth of child pays for parent and then kind of defer some of those larger refactors, would that be acceptable?
Yeah, though we need to have very good numbers, especially on adversarial input.
Right.
Not just, not just what happened to the CPU if we just change the config, but what happened is someone tries to exploit it.
So Andrea, who did the first chain transaction research in BU?
I think it was Andrew.
Okay. And maybe we could reach out to him and see if he'd be willing to kind of extend his research on that.
Yeah, we could. I could ask him.
Okay, that'd be great.
That would be good. Are there any other items to consider before we move on to some questions from the audience? No? Okay. I'm going to send out the question to the panelists. I'll read it too. I cannot pronounce the gentleman's name, Roijikku. He says, I have a preliminary Merkleized radix tree implementation. The design is primarily a flat file Merkle tree wherein we store the tree in a series of append-only files. I'd like to know if Merklix is still going forward, if not for May, sometime thereafter.
Yeah, certainly not in May though, but it's still in the plan.
Okay. Anyone else like to comment on the question?
I guess the only thing is he says he has an implementation going. I would encourage him to get in touch with developers and get some preliminary review, start writing tests for it, because the only way that the development on this moves forward is, like Amaury said, by people stepping up.
Right. Jason, you're available if somebody wants to send an email and get the conversation started?
Yeah, absolutely.
Okay. And if I remember correctly, you are Jason Cox at...
Jason B. Cox at bitcoinabc.org.
Say it again, please.
Jason B. Cox at bitcoinabc.org. You can find our emails on the site, I believe.
Right. Okay. Just want to
or
make
worst
sure
case through GitHub. You can find our emails that way too.
Okay. I trust that will get the ball rolling for this gentleman. Do we have any other questions from anyone in the audience? There are still 6 people that are attending as participants. And if you do have any questions, please forward them. It looks like not. Do you guys have any further conclusions that you'd like to share before we end the meeting? Well, I can ask the question. Do you feel this has been a productive meeting?
Yeah.
I think so.
Yeah.
Yeah, I guess that was going to be my comment is like, I think it's good just to even kind of raise our own awareness and maybe other people's awareness about the status of things and what's happening. So, yeah, I think it's been useful.
Good. We have, there's a number of things that will need to be put into a timeline coming up to the upgrade in May. And so it is our intention to facilitate as many meetings as is necessary. At the top of my head right now, I'm thinking every 2 weeks, similar to what we did prior to the fork in November. So if you guys have any comments on that, or anybody in the audience has any comments, please send them along. I will be processing the video from this call today in the next couple of days and hopefully get it up on YouTube and a variety of other sources so people can have a look and see some of the people that are working behind the scenes on Bitcoin Cash. So, anyone else have any further questions or comments? Okay. Thank you very much for attending. I look forward to chatting with you all again very soon. And thanks to the attendees as well for being here. I'll bid you a fond farewell.
Thanks for
Bye,
organizing.
everybody.
Thank you.
Bye.